Page 266. Now we're looking at question 4. Take a read through this, and I want you to try and set up the diagram on your own based on that information. So pause the video and try it all on your own, and then use my video or my solution in bits and pieces. Okay, use what you need, pause it, try it on your own, use a little bit more of what I show you, pause it, try it on your own, and see if you can get through the question like that. All right, so what I have is the runway running north to south or south to north, whatever. Departure end I put on the north end, it doesn't really matter, and there's my tree in the distance. Beautiful little tree. All right, so this is the three-dimensional problem. I still have my blue triangles from before. I cut out a little yellow strip to represent the height of my tree off in the distance. Okay, that's what we're trying to find, is the height of that tree. So my three-dimensional situation that they're giving us is the angle of elevation to the tallest tree is 4 degrees. So, trying to set this situation up with the phone between my knees, and this is kind of the situation that we have here. From the end of the runway, okay, from the end of the runway, I can look up my angle of elevation on the blue triangle to the top of the tree is 4 degrees. So if I lay this flat, this side of my triangle is representing the height of my tree. This angle in here is my angle of elevation. So the angle of elevation is 4 degrees right here. And we're going to need that information. This is the height of my tallest tree. Okay, so then it goes on to say that Dave walks 100 meters west. So if he walks 100 meters west, that is exactly at a right angle to north. And he makes note that the departure end of the runway and the base of the tree are separated by an angle of 83 degrees. So if he's standing here, he sees the base of the tree, so the line of sight to the base of the tree, and then he scans over to the end of the runway, and that would form an angle of 83 degrees. Okay, so here's my three dimensions. Again, this is what we're showing. Okay, so the tree is the height of the blue triangle off the end of the runway at 4 degrees. So I can lay it down, and now it's not 3 dimensions, it's 2 dimensions. And that's really what we're doing, is we're just trying to make sense of the problem. So here's what we have. We have 2 triangles. They're both right triangles because we're talking about due west from north. That's a right angle. The height of the tree would be perpendicular from the ground, so that's going to be a right angle triangle. Dealing with right angle triangles allows us to use SOHCAHTOA. Notice in the blue triangle, 4 degrees, we're looking for H, no other information is given on the triangle, so we can't do anything with that. But here we have another triangle. We have an angle, we have a side length, we know it's a right triangle, so therefore we can use SOHCAHTOA. We can find any other side length that we want on this triangle. So I would suggest we find this length. Okay, the length from the runway to the base of the tree. Sorry, my tree is drawn in the wrong spot there. Let's just cover it with a triangle. So there's the base of my tree. There's the end of the runway. And on the blue triangle, this length and this length on my white triangle are exactly the same. Push this aside, and I have a right triangle, 83 degrees, 100 meters, and L. Use SOHCAHTOA, find L. If you find L, you found this L. Use SOHCAHTOA again, find H, and your problem is solved. Okay, but see, my strategy is to turn 3 dimensions into 2 dimensions, make sense of the problem, see the connection between the 2 triangles that you have information 4. First of all, the one you have 2 pieces of information for, get a third, which represents a second on the other triangle. Okay, good luck.